Hello, my amazing students. This is Mrs. A, and I love math. Today, we're doing lesson 19 in our Saxon Course 3 book. We're talking about polygons. And polygons are closed plane figures with straight sides and the same number of sides as angles. Now, this lesson is going to be a little bit different in that this lesson is mostly concepts that we're going to be learning more than problems that are going to be worked. So I'm going to take you straight to the book and give you some instruction straight from the book. So I don't have to draw all of these very intricate figures on my board. Okay, so first we're going to look at example 1, and it says, which of these figures is a polygon? Now, it goes through each one and tells us why. Now, remember, if we look up here, there's the definition of a polygon. Polygons are closed plane figures with straight sides. Plane means flat. Okay, so we can see right here, closed figures would be A, C, and D, but C is not flat, and A does not have straight sides. So the only one in A, B, C, or D that is a closed plane figure with straight sides is D. So down here, they explain each one. Okay, figure A is closed, but it has a curved side, so it is not a polygon. Figure B is not closed. You see how I can go all the way inside and never hit a wall? Okay, it's not closed, so it is not a polygon. Figure C represents a cube, which is not a plane figure. Plane means flat, so it is not a polygon. Figure D is a plane, closed figure with straight sides, so it is a polygon. This is a 1, 2, 3, 4, 5 pentagon. Pente means 5, and it is a polygon. A polygon is regular if all its sides are the same length and all its angles are the same size. Okay, so here we're going to look at these, which polygon is not regular. Okay, so remember, what does it have? All the sides are the same and all the angles are the same. Well, A looks like we have the same length of each side and the same angles measures. That's what it looks like. We're gonna see more clearly in a minute. B looks regular. C looks regular. But notice that D is flatter than it is tall. So these angles are not all the same, are they? Okay, so the one that's not regular is D, but let's look at their solutions for us, okay? The sides of each figure are equal in length. The angles in figures, so basically all 4 figures have the same side lengths. Figure A, B, and C are of equal size. Okay, those are the angles that are of equal size. All of these have the same angles, but D has 2 acute angles. Remember, acute is smaller than 90, and 2 obtuse angles. These are your obtuse angles, bigger than 90. So the figure is not regular. Okay, so that is two very important concepts. Okay, regular and what is a polygon. Okay, so here we are on the top of the next page. It says polygons are named by the number of their sides and angles. So the first one that they name here on this chart at the top of the page is a triangle. We know that a triangle has 3 sides. A quadrilateral, quad means 4, okay, has 4 sides. A pentagon has 5 sides. A hexagon has 6 sides. A heptagon has 7 sides. An octagon has 8 sides. A nonagon has 9 sides. A decagon has 10 sides. A hendecagon has 11 sides and a dodecagon has 12 sides. A polygon with more than 12 sides may be referred to as an n-gon, with n being the number of sides. Thus, a polygon with 15 sides is a 15-gon. The point where two sides of a polygon meet is called a vertex. And plural, a vertex is called vertices. A particular polygon can be identified by naming the letters of its vertices in order. We may name any letter first. The rest of the letters can be named clockwise. Remember, clockwise goes around in the same direction that the clock hand goes. Or counterclockwise, it can be named this way. So one name for the polygon below is U. Now they chose to start at U, but once they start at U, they must go either clockwise or counterclockwise. So U, S, T, V is the one that they listed. What are the other 7 names? So what are we going to do? We're going to list the other name that starts with U, but we're going to go the other direction. U, V, T, S. Okay, so that's one name. Now what are we going to do? We're going to go to this one, S. S, T, V, U, S, U, V, T. Okay, and then we're going to go to T. T, V, U, S, T, S, U, V. And then we're going to go to V, last angle. V, U, S, T, V, T, S, U. Okay, so we had all of those ways that we could identify that polygon or name that polygon. Okay, so now when we move down below, we're talking about congruent figures. Okay, figures are congruent if they have the same size and shape. Figures A and D are congruent, even though they do not have the same orientation. We could say this one is laying horizontally. Remember, horizontal is like on the horizon, and this is a vertical rectangle, but don't they look like they're the same size and shape? Okay, so the orientation or which direction it's facing has nothing to do with its size or shape. So we would say that figure A and D are congruent, and it says we could slide and turn figure A to perfectly align with figure D. So if we took figure A, slid it all the way over here, set it up on its side and stuck it in front of D, it would exactly cover rectangle D. Okay, so down here below it says figures A and C, and figures C and D are not congruent because they are not the same size. They are similar because they have the same shape. Figure C appears to be a dilation or enlargement of figures A and D. So here's C. Remember, A and D are the same. C looks like maybe it's just A or D enlarged up. So that is similar. It's a dilation, which means it's just bigger than these two. Okay. And figures, using magnifying glass, we could enlarge the image of figure A or D to match figure C. Okay, or we could put figure A on a copy machine and blow it up a little bit, and it would be exactly the same size as C if we knew exactly how much to blow it up. Okay, figure B is not similar to the other figures. Okay, it looks like it's a square. These are all rectangles. It's not similar at all to the others. Okay, we use the symbol, this little squiggly sign indicates similarity. Figure A is similar to figure C. They're not congruent because this one is smaller than this one. Okay, figure A is similar to figure C. That one little squiggle means similarity. Okay, so let me get this out here. Blow it up a little bit. You see that little symbol there? That is your similarity or similar symbol. It says, since congruent figures are both similar in shape and equal in measure, we use the symbol. Now notice what it has. It has an equal sign and the little squiggle. Okay, so when we see this equal sign and the little squiggle, we know we're talking about congruent, not similar. Okay, now congruent is the equality of geometry. Okay, so we have figure A is congruent to figure D. They're really the same. They're just in different orientations, aren't they? Okay, so let's go to the next page. Okay, look up in example 3. It says, which triangles below appear to be similar and which triangles appear to be congruent? Now remember, congruent means exactly the same. They may be facing a different direction, but they are exactly the same. A and C look to be the same size and shape. It does not matter that A is facing this direction with its right angle to the right, and C is facing to the right with its right angle to the left. They're just the same figure flopped over. So A and C are congruent. A and C are congruent. B is similar in appearance to A and C. So triangles A, B, and C appear to be similar. Now D is completely different from all the others. Okay, so now we're ready to start looking at our practice set. Like I said, this is a concept section. Very few actual problems had to be worked, and so we did this a little bit differently than we usually do our lessons. Okay, so let's look at practice set A. It says, name this polygon. Is it regular or irregular? Now remember, it is a polygon. Polygons are named by their sides. So 1, 2, 3, 4, 5, 6. Okay, remember that a 6-sided figure is called a hexagon. So this is a hexagon. Is it a regular hexagon or an irregular? Doesn't this side here look longer than this side here? Okay, so, and these angles don't look the same, do they? Okay, so this is an irregular hexagon. Okay, that's the answer to A, irregular hexagon. And look at B. It says, which of the following is not a way to name this rectangle? Okay, well, let's just start with A. And let's talk about the ways that we can name this triangle. A, B, C, D. We start with A again. A, D, C, B. Okay, well, A, D, C, B is this one right here. So we know that one is okay. And A, B, C, D, that one works too. So A and B both start with A, and they are the ones that would be in the correct order as we went around. So A and B are okay. Look at C and D. They both start with B. So if we start with B, we could go B, A, D, C. Okay, B, A, D, C. So that one's good. B, C, D, A. That says BA. Okay, so this one was the right one to start. There's only one way to go once we start around. BACD. BACD. That one should be a D and a C. So C is the one that's wrong because it says BACD instead of BADC. Okay, these are kind of fun, I think. All right, let's look at C. It says, what is the name of the shape for a stop sign? Now, a stop sign, hopefully you remember what a stop sign looks like. It has 8 sides. It is an octagon, an 8-sided figure. Okay, let's look at a stop sign. Okay, well, hopefully you just saw the pictures that I put on the screen of the stop sign. But the stop sign has 1, 2, 3, 4, 5, 6, 7, 8. Now, the one I showed you was 8 equal sides. It is a regular octagon. Octagon means 8 sides. Okay, so D says the block H shown is a polygon. Count the sides and name the polygon. Okay, so here is the H that they're talking about. Well, this is certainly not a regular polygon. It is a simple, closed, plane figure. Okay, it does not cross over itself, so it is simple. Now, how many sides does it have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 figures. So remember, 12 figures over here, when we look up 12, was dodecagon. See if I can make that clear. Dodecagon is 12. So this H over here is a dodecagon. Count the sides and name the polygon. These are really pretty simple. All you got to do is count and remember your little chart there. Okay, let's look at E. And E says, use 4 letters to correctly name the figure that looks like a square. Start the name with the letter A. Okay, so we're looking at E, and here is the figure. So we're going to start with the one that looks like a square. Well, this one is definitely a rectangle. This big one is a rectangle. This one right here looks like a square. So we can, it says start the name with the letter A. So we're going to start here. We could say A, B, E, F. That's going counterclockwise. Or we could say A, F, E, B, which is going clockwise. Okay? Now let's look at F. It's getting blurry here. Let's see if I can make that a little clearer. Okay, here we go. In example 3, which triangle appears to be a dilation of triangle A? So we have to go back to example 3. Which one appears to be a dilation? Remember, dilation makes it bigger, of figure A. Well, A and C, remember, look the same. D is entirely different, but B is the one that is a dilation or an increase in size. It's just like putting it on a copier and printing it up in ratio. Print ratio is going up. It's just the same shape, but it's a little bigger. So B is the answer to E. No, what was that? F. Okay, so that was F in example 3. So that was B. Letter F was B. And now we're on G. Okay, it says, which figures below appear to be similar and which appear to be congruent? So we only have 4 figures, so you can see them right there on your screen. Okay, let's look at them. Okay, we have definitely B and D look to be the same shape, just flipped over. If I took this one and just flipped it over left to right, wouldn't it look like this one? So we're going to say that B and D are congruent, and A and B are similar. Okay, they look like you could flip this one around and make it get bigger, and it would be this one. And A and D are similar. Or we could say A, B, and D are similar. But C doesn't have any similarity whatsoever. So how would we then make those marks? Okay, how would we symbolize that? Okay, so remember that B and D are congruent. So we would write that on our little whiteboard as B is congruent to D, just like that, with that little squiggly symbol on top of an equal sign. Okay, and then remember we talked about, oops, I'm losing my board here. We talked about here in the picture that A, B, and D are all similar. They're not the same size, but A, B, and D are the same type of figure, and it looks like A is just smaller than both B and D. So we'd say A, B, and D are similar, which we could say in this way. A, B, and D are similar. The symbol for similar is this. So we could say A is similar to B, or A is similar to B. And B is similar to D. Okay, we could say that, and that would be true. Okay, so we have finished all of our practice problems. Now we're going to do regular homework problems 1 through probably 5 or 6. So hopefully you have your homework opened up. Number 1 says 1 pack of trading cards sells for $1.12. For how much would 7 packs sell? Okay, so if we know that 1 pack sells for $1.12 and we want to find 7 packs, then we could just multiply, or we could say $1.22 per pack, and we could use this and say 7 packs and multiply, and wouldn't packs cancel packs? And it gives us a little roadmap of what we're going to do. 112 times 7. Okay, well, I know that 7 times 12 is going to be $14.84, and 1 times 7, so $7.84 is the answer to number 1. Number 2 says in the 1968 Olympics in Mexico City, Bob Beeman, I can't read, it's very late, broke Ralph Boston's long jump world record by leaping 890 centimeters. The former record was 835 centimeters. How much greater was Beeman's record than Boston's record? So we had 890 centimeters was the new record. 835 was the old record, and we're trying to find out how much did he break the record by. So aren't we just going to subtract? Okay, so 0 take away 5 doesn't work, so we go over here, make that an 8. 10 take away 5 is 5. 8 take away 3 is 5. And nothing over there. 55 centimeters. 55 centimeters. Okay, now 100 centimeters is a meter. So 55 centimeters is a decent amount. Okay, and number 3, Carrie had 17 bottles in her collection. Some friends gave her more. Now Carrie has 33 bottles. How many bottles did her friends give her? Okay, so she started with 17 bottles. Now she has 33 bottles after her friends gave her more. How many did her friends give her? Isn't this just another subtraction problem? Okay, we could make it an addition problem, but we would end up solving it by subtraction. We could say 17 plus something equals 33. But the way to solve that is 33 take away 17 gives us what's left over. That had to be the bottles that they added. So 33 take away 17. 3 take away 7 doesn't work, so we borrow. 13 take away 7 is 6. 2 minus 1. Her friends gave her 16 new bottles. Good friends. Okay, so number 4 says, Kim swam 1 kilometer in 40 minutes. The length of the pool was 25 meters. About how long did it take Kim to swim each length? Okay, so the length of the pool is a length that they're talking about. So what we have is 1 kilometer in 40 minutes. And how long would it take us to swim 25 meters? Okay, so what I'm going to do is I'm going to get my big board because this is a bigger problem. We're going to start with the rate was 1 kilometer in 40 minutes. Now remember, once I have a rate like that, that's a constant that I can use over and over again. And it doesn't matter if I flip it over. At the end of the problem, they're asking me how many minutes. So I'm going to want minutes on the top. So I'm going to change this around. And I'm going to say, okay, it doesn't matter if I flip that over and say 40 minutes, 1 kilometer. It's the same conversion factor. I just flipped it over. Okay, now the other thing I know is that the pool is 25 meters. Okay, so 25 meters. Now I don't have meters, I have kilometers. So what I'm going to do is a little conversion in here. And the conversion is 1 kilometer is 1,000 meters. Okay, and now I'm going to put in my 25 meters. When we put our conversions in correctly, voila, it tells us what we need to do. Minutes is on top, and notice nothing is going to cancel it. And notice what our question was, about how long did it take Kim to swim each length of the pool? Each length was 25 meters. Okay, so notice that meters is going to cancel meters. Kilometers is going to cancel kilometers, and now I have my math all laid out for me. Okay, now remember that 25 into 1,000, 25 into 100 goes 4 times. So 25 into 1,000 is going to cancel with a 40 right there. I have a 40 on the top and a 40 on the bottom. I have nothing left. It's going to take 1 minute for Kim to swim. For Kim to swim 1 minute for her to swim 25 meters. Okay, now let's think about this. If we had right away, we could change this to 1,000 meters because that's the same thing as a kilometer, is 40 minutes. Cancel out zeros. 100 divided by 4 is 25. 25 meters per minute. 25 meters per minute. So we can check it by doing it the other way. Okay, so this is using the conversion factors. This is using a substitution and a canceling. Both ways give you that 25 meters could be covered in about a minute. Pretty cool. Okay, so now we're doing number 5. And it says, what is the mean of the prime numbers between 10 and 20? So here on my board, I've put the prime numbers between 10 and 20. Remember, 15 is not prime. So when I add these all up together, make our groups of 10. 1 and 9 is 10. 7 and 3 is 10. 20, carry the 2. 1, 2, 3, 4, 5, 6. 60 divided by 4 is 15. And wouldn't 15 tuck right in the middle? So the mean of the prime numbers between 10 and 20 is 15. Okay, so here are the numbers in number 6. It says sketch a number line and plot the approximate location of the following points. So here's a number line. Here's 0. Here's 1, here's 2, here's 3, -1, -2, -3. -2 is right here. The absolute value of -3 is +3. 1/2 is about right there. The square root of 2 is 1.412. Okay, 1.412 I think is pretty close. So 1.4, we're making just a little bit less than a half right there. So 1.4 is the square root of 2. Okay, so right here at 3, we're going to put absolute value of -3 is there, -2 is there. And we have done number 6. We've done all of your practice. We have done all of your homework up through number 6. And now you get to go do your homework. This is Mrs. A, and may God bless your day. I'm sorry this is not the most coherent video that I've ever made. I just got back from a long trip. I'm really tired, so I'm going to go to sleep.